Greetings to all the viewers. This is the concept taken from Basics of Chemistry, where MCQ questions are taken into the consideration. Earlier, we already completed series of sessions based on conceptual based, competitive examination based, research based chemistry. All are available at the channel World of Competitive Chemistry. And now it is indicated as Dr. KAVITHA Chemistry Academy. Here, so many is kind of content available regarding chemistry. You can find out at the Dr. KAVITHA Chemistry Academy channel. In an acidic medium, 10 ml of 0.25 molar oxalic acid is titrated with potassium permanganate KMNO4 solution. If the volume of KMNO4 solution required to reach end point is 10 ml, the strength of KMNO4 solution is, right? So here, volume of KMNO4 is given, strength of KMNO4 to be calculated. Here, different concentrations are provided. Strength is nothing but concentration. Here, the concentration measured in molarity, so that we need to identify the molarity of KMNO4. So for that purpose, the question is taken from the volumetric analysis part of analytical chemistry. And here, in order to get that strength or molarity of potassium permanganate, we have volumetric analysis concept, redox titration and law of equivalence. Redox titration means, so here, if the reaction which is accomplished by oxidation and reduction both together, that is set up a redox reaction. Within the same reaction, oxidation reduction taken simultaneously. Number of equivalents of oxidizing agent is equal to number of equivalents of reducing agent at the equivalent point. And in the redox titration, oxidizing agent equivalents is equal to reducing agents equivalents are possible at the equivalent point. Equivalent point is nothing but end point where the reaction got completed. The number of equivalents can be calculated by using the formula. Normality into volume is equal to N factor into molarity into volume, right? So there is a convertible factor. Normality multiplied with volume is equal to N factor into molarity into volume. Here, new term N factor is indicated. That N factor is nothing but electrons gained or else lost during the process of redox reaction. For example, if you are losing 2 electrons, N factor will become 2. The value of N factor will become 2. This is the way the amount of electrons gained or else lost during the redox process is taken as an N factor. This is the formula for the conversion of normality into molarity, and what is N factor is also manifested. Now, it is important to identify how the reaction taking place. If you are considering N factor for the calculation of oxalic acid. Oxalic acid is nothing but it is the dicarboxylic acid. COOH is the chemical composition. That is indicated as H2C2O4 oxalic acid formula. Oxalic acid, after the reaction, it is converted into 2 moles of carbon dioxide, 2 H plus ions released and 2 electrons also released, right? So this is the way 2 electron release taken place. N factor for the oxalic acid will be 2. Means it able to release 2 electrons, so that N factor will be 2. In the case of potassium permanganate, that is KMNO4. Potassium permanganate, after the completion of the reaction, this titration process, KMNO4 got converted into Mn+2, where KMNO4 reacted with 8 H plus ions and 5 electrons it able to consume, and Mn+2 will be generated. 4 water molecules will be formed. So consumption of electrons are 5, so that N factor for the KMNO4 will be 5. This is the way N factor calculation taken place by means of release or acceptance of electrons by the chemical substance. Later on, our formula we need to apply. What's the formula? Equivalence of oxalic acid is equal to equivalence of KMNO4 for this redox reaction. N1, M1, V1 is equal to N2, M2, V2. This is the formula. So here M1 denoted as the molarity of oxalic acid, which is already known to you, 0.25 molar solution, which is given within the problem. Volume of oxalic acid, we pipetted out 10 ml of oxalic acid into the conical, and N1 means in factor for this oxalic acid will be 2, just to be calculated. Then volume of KMNO4 for the titration process, volume of KMNO4 consumed from the burette will be 10 ml. This is also provided within the problem. And N factor for the potassium permanganate will be 5. This is also calculated by using formula. Only the requisite quantity is molarity of KMNO4, that to be determined, that to be calculated. If N1, M1, V1, N2, V2 are known, M2 formula we need to apply. M2 is equal to M1, V1, M1, V1, N2 by N1 into V2. So by using this formula, it is possible to calculate molarity of KMNO4. That is given as, here just to be substituted, N1 2 into 0.25 value into 10 ml consumed is equal to 5 is N2 and M2 no, unknown into 10. So if you go for this calculation, 5 is equal to 50 into M2. M2 is equal to 5 by 50. M2 is equal to 0.1 molar. The strength of KMNO4 consumed for the titration is provided here as 0.10 molar. 0.10 molar is present in the option number 1. This is the way calculation is accomplished by using equivalent formula N1 V1 M1 is equal to N2 V2 M2. So that formula is very essential if we are going with the titration process. It is the volumetric analysis. Hope you understood the concept. Thank you. This is Dr. Kavitha Kothireddy Kota.